Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2, SETG 3751. We will present about Experiment 7, which is estimation of heat capacity and entropy generation. This is our teammates, Azhan, Umar, and me, Afifah. Introduction for this experiment. Heat capacity is defined as the amount of the heat required to raise the temperature of a mass of substance by 1 degree C. The measurement of heat capacity is important to determine the entropies of each material, while the amount of entropy generated during irreversible processes such as heat flow through a thermoresistant, fluid flow through a flow resistant, diffusion, Joule heating, friction between solid surface, and fluid viscosity within a system is known as entropy generation in a thermodynamic system. Entropy is used to describe the behavior of a system in thermodynamic properties such as temperature, pressure, entropy, and heat capacity. Since that, the total value of entropy must be positive since the reaction is exothermic. Objective for this experiment is to estimate the heat capacity of different metals provided and to estimate the entropy generated when these metals are dropped in a container containing water. Scope is to discover the difference of metal used, which are aluminium, copper, and steel, to study the temperature change of the different metal used when transferred to the beaker filled with water at 28 degrees C within 10 seconds interval until the temperature reach equilibrium condition. To study the entropy change of the different metals used, the entropy change of water, and the total entropy generated in this experiment.
The magnitude of the heat lost by the metal must be equal to the magnitude of the heat gained by the water. The formula for the heat lost by the metal and the heat gained by the water is same. The formula is mCp delta T. The Cp water we use in this experiment is 4.187 kilojoule per kilogram Kelvin. The entropy change of the metal or the entropy change of the water can be negative, but the total entropy generation is positive. A process must proceed in the direction that complies with the increase of entropy principle as generation greater than zero. The entropy generation is a measure of the magnitude of the irreversibilities present during the process. The entropy generated during this process is determined from delta S equal to mCp ln T2 over T1. The total entropy equal to entropy metal plus with entropy water. The spoon in this image become red to represent heat gain, demonstrating how the hot water transmit heat to the cold spoon. Next, we move to the theory or working principle part. The general equation for the heat transfer is Q equal to mCp delta T, where m is equal to the mass of the substance in kilogram, Cp is equal to the specific heat capacity in kilojoule per kilogram Kelvin, and delta T is the change in its temperature in Kelvin. This is to provide no heat is lost to the surrounding. This is the table for the theoretical specific heat capacity. For the aluminium, the specific heat capacity is 0.9, for the copper is 0.387, and for the steel is 0.452. The reason this image indicate that the ethane pot heat up more slowly than the iron frying pan is because the ethane pot has a higher specific heat.
So now, Afifah will explain about the experimental setup.
This is our experimental setup for this experiment.
Okay, now let's continue with the methodology. First, weigh all the three types of the metals. Second, weigh the empty beaker. Next, pour 100 milliliter of water into the beaker. Next, pour Next, put the copper into the beaker containing water using metal string and heat it up to 80 degrees Celsius. Next, Next, wrap another beaker containing 100 milliliter of water with aluminium foil. Next, wrap another beaker containing Next, remove the copper from the beaker after reaching 80 degrees Celsius carefully. Transfer the hot copper into another beaker containing 100 milliliter of water wrapped in aluminium foil. Transfer the hot copper. Next, record the temperature of the water in the beaker covered with aluminium foil within 10-second interval until reach the constant temperatures. Lastly, repeat the same step from step 4 to 8 by substituting different metals which are aluminium and steel.
So now I will present about the result. So now this is all the results that we get from this experiment, which is for the three metals that we use, that is aluminum metal, copper metal, and steel metal. So what we get from this experiment, the data itself, we got the mass of each metal, the mass of the beaker, the mass of the water, the initial of temperature of the metals, initial temperature of water, final temperature of water, and each experimental heat capacity of the metals. So what we have here now is the data from the experiment. So for the top left corner, the table is the recorded data for the temperature for the three metals, which is aluminum, copper, and steel. Next, the bottom table is the entropy of each metals, entropy of water, and the total entropy of the three metal aluminum, copper, and steel. So for the right side, we have here is a chart that is the experimental specific heat of metals and the theoretical specific heat of metal. So now I will be explaining the calculation for the first metal, which is aluminum metal. So what we have here is mass of water, which is 0.0949 kilogram, and the initial temperature of metal aluminum is 80 degrees Celsius. So the first thing that we need to do is to find the specific heat capacity. So the formula is mass times Cp aluminum times delta T T2 minus T1 is equal to mass times Cp water times T delta T T2 minus T1. So for the first M, we need to use the M for aluminum, and the second M, we need to use the M for water. So substitute all the data and we can get the Cp for aluminum, which is 1.124 kilojoule over kilogram Kelvin. So after we get the specific heat capacity, now we can find the entropy change of aluminum metal, which is the formula is delta S equals to M aluminum times Cp aluminum times ln T1 over T2. Again, substituting all the data, and then we can get the delta S for aluminum, which is 0.242 kilojoule over Kelvin. So the next step, we need to find the entropy change of water. So the same formula, delta S equal to M water times Cp water times ln T1 over T2, substituting it, and then we can get the delta S equal to 0.007 kilojoule over Kelvin. Now, the last step is we need to find the total entropy generated. So the formula for the total generated entropy generated, delta S total, is that entropy of aluminum metal plus entropy of water, and then insert the data, and we can get the value for the delta S total equals to 0.250 kilojoule over Kelvin. So now I will be explaining for the next metal, which is copper metal calculation. So first thing, we already get the mass of water, which is 0.0949 kilogram, the initial temperature of metal copper, which is 80 degrees Celsius. Now, with the data that we get, we need to find the specific heat capacity. So the formula for the specific heat capacity is M copper times Cp copper times delta T, which is T2 minus T1, equals to M water times Cp water times delta T, T2 minus T1. Now, substitute all the data and calculate it, and we can get the Cp for copper, which is 0.688 kilojoule per kilogram Kelvin. So once we had the Cp for copper, we now can find the entropy change of copper metal. So the formula is delta S equals to M copper times Cp copper times ln T1 over T2. So insert all the data, and then we can get the delta S equal to 0.77 kilojoule over Kelvin. Now, next step is we need to find the entropy change of water. Using the same formula, delta S equal to mass water times Cp water times ln T1 over T2, we can find the delta S, which is 0.007 kilojoule over Kelvin. So with both entropy that we get, we now can find the total entropy generated, which is the formula delta S total um, equals to delta S copper plus delta S water. Um, Calculate, and then we can get the delta S total for the copper is equal to 0.484 kilojoule over Kelvin. So for the last calculation of the metal, which is steel metal, the same step as the two metals before. So we get the mass of water and the initial temperature of metal. First, we need to find the specific heat using the formula M metal times Cp. I'm sorry, M steel times Cp steel times delta T equals to M water times Cp water times delta T. Substituting it, we get the Cp for steel, which is equals to 1.124 kilojoule over kilogram over Kelvin. Next, we find the entropy change of steel using the formula delta S equals to M steel times Cp steel times ln T1 over T2. So substituting it once again, we get delta S equals to 0.242 kilojoule over Kelvin. Now, next, we can find the entropy change of water using the same formula, delta S equal to M water times Cp water times ln T1 over T2. Substitute all the data that we get, and we can get the delta S equal to 0.07 kilojoule over Kelvin. Okay. Adding the both entropy change of steel metal and entropy change of water to get the delta S total, and we can get the value of the delta S total equal to 0.250 kilojoule over Kelvin. So now for the percentage error, we can calculate the percentage error of all the metals, which is aluminum metal, copper metal, and the steel metal. So the percentage error for aluminum metal is 24.89%. For copper metal, it's a little bit higher, The percentage error is at 77.78%. And lastly, for the steel metal, we get it's equal to 12.61%. Now, I will talk about the discussion. So, the overall entropy generation value cannot be negative, but the variation in the system's entropy can be positive, negative, or zero. The increase in entropy principle states that the entropy of an individual system increases during an irreversible process. Azhan greater than zero. Without knowing the details of the processes, entropy change can be calculated. The entropy progression of a reversible process is zero, and the entropy shift of a system is equal to the net entropy transition. The entropy equilibrium is similar to the energy balance. Copper, aluminum, and steel achieve total entropy of 0.77 kilojoule over Kelvin, 1.124 kilojoule over Kelvin, and 0.395 kilojoule over kilogram respectively. Aluminum produces more entropy than copper and steel in terms of absolute entropy. So now, we move to the sources of error and method to minimize the error. We concluded that the obtained result is not reliable after comparing the experimental and theoretical result. There are few aspects that lead to the experiment's inaccuracy. One of them is the state of the room, which include the fact that the fans are not switched off and the windows are not closed. As a result of increased surrounding airflow, more heat is drained from the system. There are also impurities of metal and in water, such as dirt, metallic compound, and other chemicals, which can affect the accuracy of the result, since we only consider the specific heat capacity of pure water and pure metals. In addition, the parallax error in reading of the thermometer contributes to the result error. Aside from that, when we transfer metal from hot water to the calorimeter, there is hot water that sticks to the surface of the metals.
Okay, this is all of the safety procedure that we use in this experiment. First, transfer the metal from the hot water using a metal string carefully to avoid any injury like hand burns and others. Second, the eye must be perpendicular to the reading of the scale to avoid parallax error. Third, make sure the digital scale is set to zero point 0.0 gram before using it. Fourth, wear a lab coat and close shoes when doing experiment to avoid any incident in the lab. Lastly, hair in a neat condition for male and non-Muslim student to avoid injury. Okay, this is all of the difference that we use in this experiment. I think that's all from us. Thank you.
I think that's all from our group, and thank you.